Every day, police departments make decisions about where to patrol, who to watch, and how to deploy resources. Now imagine if those choices weren't made by humans, but by an algorithm. Welcome to Predictive Policing, where data models claim to forecast crime before it happens. Supporters say it makes policing smarter and more efficient. Critics say it amplifies bias and blurs the line between prevention and prediction. In this new series from Curious Modeling, we'll explore the science, the math, and the moral tension behind crime analytics, how the models work, what they get wrong, and what happens when the pursuit of safety meets the limits of data. Because every prediction carries power, and in policing, that power can change lives. Let's talk about the big idea. Predictive policing grew out of the idea that crime isn't random, it's patterned. Think of it like weather forecasting. If you know what conditions tend to produce storms, you can predict when and where they'll form. Analysts use data like past incident reports, arrest records, calls for service, and environmental factors. Things like lighting, housing density, or liquor stores nearby. Combine that with time of day and location, and you get a model that says, hey, this block on Friday nights at 11 p.m., 30% higher chance of burglary. The theory is simple. Put officers where crime is likely, not just where it's already happened. Now let's cover the two main approaches. Predictive policing usually comes in two flavors. The first is place-based models. These focus on where crime will occur. These create hotspot maps. The second is person-based models. These focus on who is likely to offend or re-offend, assigning risk scores to individuals. Place-based systems, like PredPol used in Los Angeles, use methods like regression, clustering, or machine learning to identify spatial temporal risk zones. Meanwhile, person-based systems, like Chicago's infamous strategic subject list, go further, trying to predict who will be involved in future violence based on past associations. Both approaches promise efficiency, but both come with some serious ethical baggage. Now let's talk how the math works. At the heart of it all are predictive models. Think logistic regression, decision trees, and ensemble methods. They take predictors like time of day, neighborhood characteristics, previous crimes nearby, demographic and social network data, and output probabilities. A simple model might say, given the past month of data, the likelihood of a theft occurring in this grid cell between 8 p.m. and midnight is 0.23. That's a probability, not a prophecy. And just like weather forecasts, it's only as good as the data you feed it. If your data is biased, say, more patrols in poor or minority neighborhoods, then your predictions are really just reflections of where you've already been policing. That's not predicting crime, that's predicting police presence. So what's next in the future of crime analytics? The future of crime analytics may not be about predicting crime at all. It might be about predicting community need. Imagine using similar data models to forecast where youth programs could reduce violence, which neighborhoods are at risk of housing instability, or where social investment might do more good than patrol cars ever could. That's predictive prevention. And it's what a truly ethical data future could look like. Because technology itself isn't moral or immoral. It's the choices we make about how to use it that decide whether we're building safety or systems of control. If you found this interesting, we're just getting started. In this series, we'll dig deeper into how these models are built, how bias creeps in, and how cities around the world are wrestling with algorithmic policing. So subscribe, hit the bell, and join me next time as we map the math behind the badge.